In this lesson, we're going to talk about linear models. Well, what are linear models? In linear models, think line. In other words, any kind of data that can be represented with a line. And the data we're talking about probably comes from scatter plots. For example, I have shoe sizes, US and European sizes. Yet they definitely measure things differently in Europe. So we're going to graph this data and see if it's a linear model. So first we need a graph. There's our graph. My US sizes are on the bottom. Okay, so US sizes. And then these are my European sizes over on the y-axis. So we're going to graph our points. Those are our points. So 1, 31, 3, 34, and you can see how they are just on the line there, on the graph there. The next thing I'm going to do is I'm going to draw a trend line. This will tell me really if it's a linear model. And the trend lines that we draw are just generally what does it look like the data is doing. So there's my trend line. It goes right through pretty much all the points. If I want to do an equation of the trend line now so that I can maybe look at predicting some things, you'll notice my slope is 5/4, and you can look at that, and my y-intercept is 30. So remember, my y-intercept is right here. That's where I got my 30. And my slope, I went up 1 box and I went to the right 2. But 1 box is how many sizes? It's 5 sizes. 1 box to the right is how many? It's really 2 US sizes. So plus 2, that gives me a plus 4. And that's where those numbers came from. So this will give me an equation of that trend line. Y equals 5/4 x plus 30. Once we have the equation of the trend line, we can do an awful lot of things. We can do what's called interpolation. Interpolation means how do sizes equate within the data that we're given. So if I wanted to look at a size 9, if I wanted to look at a size 8, so a size US 8 would be probably close to a 40 in European sizes. So, you can look at interpolating the data. You can also look at extrapolating. Extrapolating is something that's beyond the data that we have. So you can either extend the graph, or you can take our data and you can substitute it into the equation of the trend line. And what I would do for this is I would take my 18, my US size 18, and I would substitute it in for x. So y equals 5/4 times 18 plus 30. And that will give me about a 42 or 43, 52 or 53 in European sizes. Okay, do you understand the difference between interpolate and extrapolate? Interpolate is between the data that you're given. Extrapolate is beyond. It's to one side or the other of the data that's shown in the graph. Okay? There are several types of correlation. We have positive correlations, we have weak, and we have strong. The difference between weak and strong is how far apart the data is. Notice that the band for a strong positive is much narrower than the weak positive correlation. So that's the difference between the two. Positive correlation says that the two values are both increasing at the same time. We also have negative correlation, and again weak and strong. And then there's something called no correlation, which means the two things that we're trying to measure really don't show any interaction. There's no relationship between the two. Trends can be linear or nonlinear. Right now we're going to look at linear trends. Later on, as we talk about quadratics, we might talk about nonlinear trends. But for right now, we're just going to stick with the linear trends. We can also take a word problem, and we can calculate, we can come up with an equation and graph that as well. So for this particular example, we have Jacksonville, Florida, with an elevation of 12 feet above sea level. A hot air balloon taking off from Jacksonville rises at a rate of 50 feet per minute. Very important, okay, I'm going to point this out. Rate, okay. Write an equation that represents the situation and then graph the path of the balloon. So the rate, guess what rate is? Rate is your slope. And 12 feet, your elevation of 12 feet above sea level, that's your starting point, so that's your y-intercept. So remember, rate, rate of change, slope are always the same thing. Okay? So that's how we got our equation. We then take that equation and we can graph it. And from here, again, we can interpolate any answers. So at 2 minutes, the balloon is at approximately 120, approximately 120 feet. If we're looking at 4 minutes, well, now we're off the chart. So if I wanted to know how high the balloon was at 4 minutes, I would substitute that in. So we would do y equals 50 times 4 plus 12. 50 times 4 is 200, so it would be at approximately 212 feet high. I hope that makes sense. I look forward to the next lesson.